I'm Joe Giuliano, and today I'll be presenting Lab 2 Projectile Motion. So here's our introduction. So for our background, we had an eraser and we threw it as projectile. And then we recorded this motion in Tracker, the projectile motion, and we modeled it in both GlowScript and Excel. And so our purpose was to observe and predict the motion and trajectory of this object, or eraser, using a computational model. And so we used our computational model in GlowScript along with Tracker and Excel to map the 2D motion. And then we found motion with and without the effects of drag force. And we calculated our drag coefficient to be 0.0188. For our introduction, continued, we have our principles of forces, Newton's second law, projectile motion, and then using X and Y components, unlike in Lab 1, where it was just in one direction. And then we have models used in this lab. We have the scatter plot model in Excel. We have our data plot in Tracker, and then our two models in GlowScript, which are with and without the drag force. We have the equations used in this lab. So we have V average equals delta V over delta T, which is our average velocity equation. We have the drag force, which is negative BV squared times V hat, where B is drag coefficient, which we calculate by analyzing our Tracker data. And then we have the force of gravity 0, negative mg 0, so it's only in the y direction. And then we have our position and velocity update formulas, which are the same as in Lab 1. Here are our initial conditions. So we have the pink coordinate plane. We have the two blue lines to calibrate our meter sticks to show that they're a meter long. And then we have our eraser, which is a mass of 41 grams that we threw, as you will see in the next slide. And then we have the force applied assumed to be 0. So it starts with initial velocity, but not with an initial force pushed by us. The only force acting is gravity and drag force. So here's our experiment. Here's the video. So as you can see, it follows this trajectory here. And so we recorded it in 2D projectile motion, not 3D, just 2D. And then we imported the video to Tracker, created our origin using the pink and blue lines. We recorded our data, and each video frame, it moves on. So all these diamonds here are every 0.33 seconds of the video. And then we created two computational models in GlowScript with drag force and gravity, and then one with just gravity. And then we modeled them in Excel. And so here's our code. We have our initial conditions here. So we have the mass, we have the initial positions relative to the origin. We have the initial velocity calculated using the average velocity formula in the X and Y directions. And then we have delta T, which is 0.033 seconds. So that's the time step. And then we have gravity is G is 9.8, which is gravitational constant near Earth. And then we have B, which is our proportionality constant for drag force, which we calculated by making sure the final position of the X direction was equal to our final position of the X direction in Tracker when we modeled it in GlowScript. And so here's our calculation loop here. It's using Newton's second law. And so here's our computational model. As you can see, it looks very similar to what we had in Tracker. So here is what we modeled in Excel. So for the green, you have the Tracker data. For the orange, you have the trajectory with just gravity, no drag force. And then in red, you have the trajectory in GlowScript that was drag force and gravity. And so each trajectory pictured is pretty similar. And they all end up at the same X coordinate. The only difference is most likely due to it not being able to fully edit out the force applied from the Tracker video. So you can see here the Tracker one is slightly different than the orange and red ones. So for a discussion, we have our what ifs. So if the object were thrown straight up, you'd only be taking the y direction into account. So that means that if you had drag force, the drag force would only be going upwards, so it'd be greater than the components of x and y directions for when the drag force is opposing the motion. And so, but if there's no drag force, then it takes the same amount of time to reach the ground. With terminal velocity, there's nothing here that shows terminal velocity, but if you wanted to make an experiment that did do terminal velocity, you could drop an object from a high place and record that, and then find when the velocity becomes constant, because that'll be when you have terminal velocity. To conclude this lab, we used Tracker, GlowScript, and Excel to calculate and model the trajectory of our eraser moving a projectile motion. So we used GlowScript to find a drag coefficient of our Tracker data, created two computational models, and then used Excel to plot the trajectory of these three models. And so this lab taught us how to model 2D dimensional data as well as analyze and depict these forces acting on a two-dimensional system. And finally, our assumption and source of error. So we assumed that there was no force applied at the beginning. We assumed that there's no drag force in the first computational model, but not the second. And we assumed the origin to be the tabletop. And for sources of error, we had the vertical ruler being slightly askew. We had data points on tracker not being 100% accurate because of human error, as well as some computational errors possible, calculating velocity and drag force. And that's it. All right, thank you.